Hello everyone, welcome to my class. As you know that the world of business is very big, but also in the world of business it is very crucial to study one of the very important discipline that is called statistics. As we know that in statistics one crucial component comes in our mind, the first topic that usually students face is correlation. In this short video, I will tell you about this topic from a very basic point of view, and we will try to go deeper in our lessons later. So we will study two topics today. What is correlation in statistics? And we'll also study how to measure correlation between variables by using the technique which is the first technique and one is the most common technique that is called scattered diagram or scattered diagrams. So we will study about correlation in statistics today, and now let's try to know correlation. Correlation is one way of analyzing statistical data. We all want to say something about data, right? We all wanted to predict about the population. We all wanted to say something about the population. We all wanted to study the samples. But in order to study or say something about it, we have to use some tools. And one tool which can help us in saying something about the data is correlation. So actually correlation is a way of analyzing data and it is an amazing tool. Next thing is we have is correlation is systematic process of examining relationship between two or more variables. You know, you can do correlation, you can use it as a tool, but you have to follow a systematic process. It's a systematic way. It has some set of rules, formulas by which you can find the relationship between two or more variables. So it's actually a systematic way. It's not like a hit and trial, it's actually a systematic way of doing something. Now, one more thing we have to see is that it sees the intensity and direction of relationship. See, correlation only measure the intensity, that how much strong the relationship is, and also measure in which direction it is going. Either it is going in a positive direction or either the relationship is going in a negative direction. Now it can be a bivariate analysis of the data or it can be a multivariate analysis. In a bivariate analysis, we only do comparison of two variables. We try to know their relationship, but in a multivariate analysis, we compare two or more variables and we try to know their relationship. Correlation study variables even if there is a coincidence between them or a cause or effect relationship. See, even if two variables have cause or effect relationship, for example, uh, ice cream has a relationship with summers. So it can be cause or effect relationship or it can be a coincidence. Maybe there is a no relationship between uh, two variables. For example, there is no relationship between summers and wearing shoes. It is not a direct relationship, but a correlation does not need any kind of relationship to study two variables. It can be a relationship of cause or effect, or there can be no relationship, which we usually call it as coincidence. Correlation is of two type. You must know that it is a positive or negative correlation. As I already told you about the direction. The direction can be positive or it can be negative. Correlation study the direction as well. So correlation is actually of two type. In basic way, it is of two type, positive and negative. You know, in statistics, whenever we measure or analyze data with the help of correlation, we define it with an identity symbol that is called small r. Now we can measure correlation between variables either by showing how much the relationship is by we can show it by measuring it in number called numerical value, and we can also show the relationship with the help of diagram. So in order to analyze the data with the help of correlation, we have two ways. We can show how much the relationship is with the help of a number, and we can also show that how much the relationship is with the help of a diagram as well. So these are called techniques of measuring correlation. So correlation can be measured with these three very basic techniques. One is we have a diagram that is called a scatter diagram. When we have Karl Pearson coefficient of correlation, which is actually a numerical value, and when we have Sperman rank correlation, which is actually a numerical value. So we can measure correlation of a particular data. We can show the correlation with the help of a number, or we can show the correlation with the help of a diagram. As we know, in our today's class, we'll study about a very basic topic, that is scatter diagram. And so we can analyze the diagram and we can see a numerical value and we can measure the correlation. So this is something very basic features of correlation, and I will try to tell you one thing, that correlation exists between -1 to +1. So a correlation which is -1 is negative correlation, high level of negative correlation. Correlation can be 0.5. Correlation can be 0 as well when there is no relationship. Correlation is 0.5, correlation can be 1. So this is how the range goes, -1 to +1. Always remember, correlation goes from -1 to +1 range. So R cannot exceed it or go beyond, or can be less than -1, more than -1, or can be more than +1. So let's study about the scatter diagram, which is the first technique of analyzing data with the help of correlation, which is very simple. Very simple. It cannot tell you precisely how the correlation is, but it can tell you on a paper or a diagram that how much the correlation is actually between the variables. So when we visually, you have to see it. When you visually analyze we're actually visualizing, we are seeing a picture and we're trying to analyzing with the help of picture. There will be no calculation of any numerical variable. There will be no numerical value. We will find out to see the correlation. We'll actually see diagrams. So if you see these diagrams carefully, you can see the first diagram. It's a perfect positive correlation. Now why it is positive? It's actually positive because both the variables are moving in the same direction. And according to our previous understanding, we know that correlation measures direction as well. So it's a perfect positive correlation. It's perfect because both are moving exactly in the same way. If one thing increased by +5, another also increased with +5. If height increased by 5 centimeters, weight also increased by 5 centimeters. 5 kg, right? So the variables are changing in the same intensity. Okay, so now let's see the highly positive correlation. A highly positive correlation is one which is close to perfect, but it's not perfect. So we can say the R is 0.8. So a perfect correlation will be one which is +1, and little lower than that, 0.8 means it is close to perfect. Now we will go more lower to 0.3, in which is called low positive correlation, but its variables are positive, they're moving in the same direction, but the relationship or the intensity between the variable is not that much good. Now the last one is 0. It means there is not even a single point which shows that there is a relation between both the variables. Neither it is negative, neither it is positive, and it is far away. Points are plotted far away of both the variables. There is no correlation. Whenever there is no correlation, it is always 0. Now we have on the right side of our slide, we have low negative correlation. Low negative correlation means let's start with 0.3. 0.3 stands for there is negative correlation. It means variables are moving in opposite direction, and also they don't have any relationship. Now high negative correlation is -0.8. It means the variables are moving in opposite direction. One thing is increasing, another is decreasing, but the relationship is close to perfect. Now perfect negative correlation is absolutely perfect. It means both the variable are moving in opposite direction, also moving with the same intensity as well. It means if one thing is increasing with +5, another thing is decreasing with -5. So a correlation is verified by variable r, and it can never be more than +1 and never be less than -1. And three things are very crucial here. +1 means perfect, -1 means perfect but it's negative, and 0 means there is no correlation. Anything between them can be called as highly or low. Now, one important thing I want to tell you about in this particular chapter regarding scatter diagrams is that if you see a perfect positive correlation or if you see a perfect negative correlation, it is a linear correlation. But it is also true that if you see a highly positive correlation or if you see a highly negative correlation, it means variables are very close, very, very close. Not perfect, but they're close. It is still called a linear correlation. So, linear correlation exists whenever the variables are close to each other and it is linear, and it is a linear correlation. I'm really sorry for that low positive correlation, a linear correlation. So we have removed it. So whenever you see a highly positive correlation or a perfect positive correlation, you will say it as a linear correlation. Also, if the relationship is highly negative correlation and there's a perfect negative correlation, you can also say it as a linear correlation. So what we have studied today is about correlation. What is the meaning of correlation? Its amazing features, which are very crucial, and also we study that how important it is uh, to see it with various techniques. And there are three amazing techniques in very basic part of this chapter is that scattered diagram, Carl Pearson, coefficient of correlation, and we have Spearman rank correlation. But in order to visualize the diagrams and tell how much the correlation is with the help of only with the diagrams, it is we are not using a numerical value. We are studying today our one topic called scatter diagram. Scatter diagrams are visible in front of your screen. These are the diagrams which we actually use to see how much the correlation can be. Remember, it cannot be more than +1 and cannot be less than -1. And +1 stands for perfect, which is also called linear. If it is close to perfect, it means it's still high. It can also be said to as linear correlation. So we have studied some good features of correlation along with the scatter diagram. So thank you so much, everyone. So we will see you in another lesson of correlation. Um, Thank you so much.